Bismillah ar-Rahman ar-Rahim. The second class of antibiotic is the protein synthesis inhibitors. This class include aminoglycosides, tetracyclines, macrolides, chloramphenicol, and lincosamides. The first group is aminoglycosides. Basic structure of aminoglycoside is the aglycon part, aminocyclitol, aminocyclohexane, triol, aminocyclohexane, tetrol. So this is the aminocyclitol or aglycon. Two aglycon. Streptidine contain two aminoguanidine group at 1 and 3 position, and deoxystreptamine containing 2 amino group. Member of aminoglycosides include streptidine class, streptomycin, deoxystreptamine class, kanamycin, gentamicin, and neomycin, 3 subgroups. Mechanism of action of aminoglycosides as following. Aminoglycoside irreversibly bound to 30S ribosomal subunit, result in shutdown of protein synthesis or result in defective protein biosynthesis. And this is bactericidal, active against gram-negative aerobic. Aerobic because aminoglycoside is very, very polar, so transferred inside the bacterial cell through active transport. So need ATP. Streptomycin, first member, aglycon, streptidine, and 2 sugars, deoxystreptose, and this contain aldehyde as a terminal, and N-methyl glucosamine. Both sugar attached at carbon number 4. Kanamycin, deoxystreptamine, and 2 sugars, 2 amino sugars attached at carbon number 4 and number 6. So different than streptomycin. Here is amino guanidine base, 2 groups, is amino group, deoxy, and 2 sugar at 4 and 6, but here the 2 sugars are attached at 1 carbon. Tobramycin, other member of kanamycin, 2 sugars, amino sugar at 4 and 6. The difference between tobramycin and kanamycin by substitution of hydroxy group by amino group. So tobramycin is more active against gram-negative bacilli. Neomycin group, just said subgroup, neomycin, aminocyclitol, deoxystreptamine, 3 sugars. So we can speak about this point. 3 sugar. How aminoglycoside absorb it? Active transport. Is it used orally or parenteral only? If used for systemic, it should be administered by parenteral. If used for local effect, can be used orally because not absorbed from GIT because due to the high polarity. It can be used also topical and local. Topical as cream, local for as ointment, eye ointment, eye drops. How can aminoglycosides eliminated from the body? Elimination mainly through active secretion. So aminoglycoside overload nephrons, lead to nephrotoxicity. As the aminoglycoside polarity increase, nephrotoxicity will be increased. So neomycin contain 3 sugars, more polar, more nephrotoxic, so that its use is restricted only for local effect, either in GIT or topically through eye drops, eye ointment, or creams. Second member is bromomycin. This is neomycin group, deoxystriptamine, and 3 sugars. Aminocyclitol, sugar, ribose, and 2 amino sugars. Gentamicin group, like kanamycin, this is 4 and 6. This 4 and this 6, not 1 and 3. 2 amino sugars is natural sugar. Is this usual sugar? No. Sugar, a numeric carbon, 1, 2, 3, 4, 5, 6, 7. Heptulose, deoxy, dideoxy. So it's a natural sugar. Due to a natural sugar of gentamicin, they are very active against gram-negative bacilli. Second thing, more lipophilic than the other member of aminoglycoside. Metilomycin, other member of this group, unusual sugar. So aminocyclitol, 2 amino sugar are unnatural, unusual sugars in gentamicin, and this is a big difference between kanamycin and gentamicin group. Mechanism of aminoglycoside resistance through microorganism. Microorganism can resist aminoglycoside in each of the following. First, reduce aminoglycoside entry, or enhance the efflux through glycoprotein B 120, or through modification on aminoglycoside, adenylation, phosphorylation, and acetylation. The most dangerous one is the acetylation, because acetylation occurs at the essential amino group in aminocyclitol. How to avoid modification of the structure of kanamycin group? By acylation at the site of resistance at amino group, which was acylated, resulting in inactive. To make it active, the acyl group should contain another replacement amino group. So amino function still here, result in amikacin, more active than kanamycin group, more resistant to bacterial inactivation enzyme. Amikacin used by intramuscular or intravenous. Second group is tetracycline. Tetra 1 2 A B C D 4 cycle tetra cycle nafcine partially reduced amphoteric dimethyl amino group is basic 3 hydroxy conjugated with carbonyl alpha ketol beta ketene pKa 3.3 acidic complex stereochemistry 1 2 3 4 5 sites slight sensitive due to hydroxy and site of oxidation at 12 have bitter taste, so if used orally should be converted to water insoluble. It's almost water insoluble, most sparingly water soluble in water. Chelate with divalent metal, site of chelation between OH10 and carbonyl at 11, carbonyl at 11 with OH at 12, OH at 12 with carbonyl at 1. All these sites are sites for metal chelation, especially divalent metal. This will discuss more detail in tutorial class. Tetracycline almost unstable in acid, base, and neutral pH. So this drug needs specific care. Mechanism of action by inhibition of 30S ribosomal subunit according to concentration. If high concentration, it will be bactericidal. Low concentration, it will be bacteriostatic. Chemical stability at weak acidic pH, epimerization occur at carbon number 4. Dimethyl amino will be converted from alpha orientation to beta orientation. Epitetracycline is only 5% activity or almost inactive. Acidic pH, we will deal with OH at carbon number 6. 1, 2, 3, 4, 5, 6. Carbon number 6. This carbon is sensitive to pH if contain OH. First, at pH of stomach, pH 1 to 2, dehydration occur as follow. There is a anhydrotetracycle. Ring C and D become aromatic, and this inactive. Alkaline pH, also pH number 6, attack carbonyl, result in breakdown of ring C and forming lactone structure. Isotetracycle, inactive. So if you need stable tetracycline, it should contain no OH at C6. Commercially available tetracycline, representative examples: tetracycline, oxy, chlorotetracycline, dimethylcycline, doxytetracycline, doxycycline, and aminocycline. If we look to the first 4 member, OH at R1 or R2, OH, 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 red color. All these 4 tetracyclines are orally inactive, unstable in acidic and alkaline pH. So mostly used as cream or ointment or as oily injection. Doxycycline have no OH at C6. H and CH3. So the most commonly used oral tetracycline is doxycycline, used for acne, for vibrio cholera, and so on. Minocycline, orally active, no OH at C6, but contain dimethyl amino at carbon number 7. What is the effect of dimethyl amino? Dimethyl amino is electron releasing group. Release electrons to ring, so decreased polarization of phenolic OH. Result in increased lipophilicity of tetracycline. So easy to cross blood-brain barrier in concentration that effective as prophylactic in meningitis. So tetracycline is named meningitis, minocycline. Oral, more lipophilic, longer duration. So, in conclusion, beta ketone for acetate, dimethyl amino is essential, or ring A is essential. Dimethyl amino should be alpha orientation. Monoalkylation by methyl group reduce activity, but amino alkylation, so methyl amino again, amino methyl result in prodrug. Electron donating or electron withdrawing at carbon number 7 enhance activity. Removal of C6OH increase stability. First member of intravenous water-soluble tetracycline is Rolly tetracycline, prodrug. Methyl at the amino group and containing amino group. So methylene between two nitrogen. It's a prodrug, Rolly tetracycline. How it prepared? By Mannach condensation between pyrrolidine and tetracycline in presence of formaldehyde. Mubicycline, amino alkylation, prodrug. It used as mubicycline penicillinate. Gram positive and gram negative. Gram positive penicillin and gram negative tetracycline. Act on protein synthesis, act on cell wall biosynthesis. So synergism effect. Amificol. Chloramphenicol. This is the first or prototype of this group. Stereo, 2 asymmetric center. Orientation is 3 orientation. It contains nitro group, 2 hydroxyl group, 1 secondary alcohol, and 1 is primary alcohol. Acetamide, dichloroacetamide group. Chloramphenicol, white crystalline, but is stable at normal condition, unlike tetracycline. Very soluble in alcohol, but slightly soluble in water. Have bitter taste. This is a big problem. Water solubility and bitter taste. How to solve both challenge? Mechanism of action as bacteriostatic through inhibition of 50S ribosomal subunit. Structure activity relationship, electron withdrawing group, nitro or methyl sulfonyl increase activity, but electron donating result in inactive compound. Oxidation of secondary alcohol to ketone abolish the activity. Primary alcohol esterification result in palmitate, result in oral if water insoluble as palmitate, or parenteral if make hemisuccinate ester product. We can also produce phosphate product, phosphate ester. Phosphate ester used as chloramphenicol eye drops. Please investigate chloramphenicol eye drops. You will notice it should be kept in refrigerator. Discuss. Dichloroacetamide, if replaced with trifluoroacetamide, it will be more active product. Method of assay of chloramphenicol. Predict nitro group reduction to amino. After that, diazotization, detection potentiometric, or coupling with proton Marshall, detection colorimetric. Alcohol is not group for identification for assay. Dichloro oxygen combustion will result in releasing organic chloride as ionized by Volhard assay. Macrolides, antibiotic, active only against gram-positive. So this is a substituent for penicillin if patient with hypersensitivity for penicillin. Have better taste. It's a challenge. Mechanism of action through inhibition of 50S ribosomal subunit. Characteristic of the structure: macro, large structure, large ring, 12, 13, 14 membered ring as lactone, so that macro lights cause lactone, containing 2 sugar, glutinous sugar at C3, and amino sugar, dizosamine at C5. Amino group can form salt, either water soluble or insoluble. Hydroxy group of amino sugar, we can make esterification, either water soluble or water insoluble. 3 challenges, therapeutic challenges with erythromycin macrolide. First, bitter taste. Second, acid stability in case of oral preparation. Third is narrow spectrum. How to overcome these challenges? First, bitter taste. Make water insoluble product, ester product at amino sugar OH, or salt product propionyl ester, small, but salt with lauryl sulfate, organic with organic, lauryl sulfate and erythromycin. So become water insoluble, must get better taste. Or formulation as enteric-coated forms. Acid stability. Why erythromycin is acid unstable? Due to acid catalyzed ketal inactivation. OH group at carbon number 6, again 6 with tetracycline, and again here with erythromycin. OH at carbon number 6 attack to carbonyl at carbon number 9 to result in ketal, and this inactive. How to avoid? Through esterification of OH at carbon number 6 is by methyl ether. So clarithromycin. Clarithromycin, orally active, stable, more oral bioavailability, and metabolite as hydroxy, 14-hydroxyclarithromycin, also active. So clarithromycin is active, 14-hydroxyclarithromycin also active. So longer duration. So first, we make esterification. Another choice to solve ketal formation, to remove ketone group at C9. Removing ketone group at C9, so will not form ketal. Insertion of amino group, so large macrolide, 15 membered ring, as a light, azithromycin. Azithromycin overcome acid instability challenge and also enhance gram-negative activity due to the inserted amino group at number 10. Extended duration, azithromycin taken once daily. Third choice, remove ketone at scene number 9 and insert amino group, so cannot form ketal. Result in erythromethylamine. But erythromethylamine have poor oral bioavailability. To overcome this, it converted masked amino group in ring structure as erythromycin. Erythromycin, orally active prodrug. By metabolism, we're releasing erythromethylamine. Telithromycin, keto light. What is mean by keto light? Keto, because no sugar at C3. No sugar at C3. Instead of inserted as carbonyl. Cladinose removed and the OH is oxidized to keto. So keto macrolide. But carbon number 9 containing carbonyl. So the first choice to make esterification of C6OH as clarithromycin. In addition to addition of carbamate. Carbamate will increase the activity. Last group is lincosamides. Lincosamide, clindamycin, and lincomycin are sulfur-containing antibiotics. This is the lincomycin. Amides, sugar with pyrrolidine, inhibit 50S ribosomal subunit. Clindamycin, like lincomycin, but the difference, removal of hydroxy group and insertion of halogen or chloro. Both clindamycin and lincomycin are active against gram-positive and non-spore-forming anaerobic bacteria. So it is drug of choice for treatment of gum infection after tonsillectomy. Most of orthopedic prefer clindamycin. After GIT surgery, it's a good choice because inhibition of anaerobic bacteria. Post structure containing pyrrolidine, basic nitrogen, we can make salt. Post structure containing sugar OH, we can make ester as palmitate water insoluble or phosphate water soluble. Any dismethyl in both result in active metabolite. How to prepare clindamycin from lincomycin? By cyanyl chloride. Cyanyl chloride, remove hydroxy and insert halogen or chloride. But look, stereoisomer, stereo configuration R in lincomycin, in clindamycin is S. Inverted configuration. This is SN1 or SN2? Good, SN2. SN1 result in racemic, but SN2 result in inverted configuration.